Hello guys and welcome to Sifasok Academy the Intellect on YouTube. In this channel we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. And we do that in all the advanced level science subjects because we're a team of teachers that perform that function best. In this video we are looking at June 2020 advanced level physics with paper 2, that's advanced level physics paper 2 section 1. I'm looking at question 6a. Question is on thermal physics. It said Roman 1c, state the first law of thermodynamics. The next part, they said 2.00 kilograms of water has a volume of 2.00 times 10 to the negative 3 meters cubed when in the liquid state at 100 degrees Celsius. That is when in the liquid state at 100 degrees Celsius. When the water is completely changed from liquid to vapor at 100 degrees Celsius under a constant atmospheric pressure of 1.01 times 10 to the 5 Pascal, the volume increases to 3.38 meters cubed. Roman 2, how much work is done against the atmosphere as the water changes into vapor? Roman 3, what is the change in the internal energy of water during vaporization? So we'll go directly to the solution. The first law of thermodynamics is the same thing as the conservatory law. So it states that the total heat transfer into a system is equals to the total internal energy of the system plus the work done on the system. So we can write the mathematical expression. We have delta Q is equals to delta U plus delta W. So after writing the literature part of the law, you can still write the mathematical expression. Okay, now the Roman 2 part says we should find the work done. Work done is delta W, which is P delta V. Now this delta W here is as a result of delta V. So now we collect our data without forgetting that in science it's good that when you are solving, you always solve alongside with your data. Always collect your data in all situations. Even if you don't know a question, first of all collect the data and ally like that. If you don't know the question, collect your data first. So V1 is 2.00 times 10 to the negative 3 meters cubed. V2 is 3.38 times 10. That V2 is 3.38 meters cubed. P is 1.01 times 10 to the 5 Pascal. Okay, so we find first of all delta V because we are going gradually, step by step. Science is the systematic study of nature, so step by step, you go step by step to find W. So first of all find delta V, which is V2 minus V1. You can punch your calculator, is 3.378 meters cubed. So now we replace now into our term of delta W, which will be 3.378 meters cubed times 1.01 times 10 to the power 5 Pascal, which is, you can still punch your calculator, 341,178 joules. Okay, now as a science student, to always get used to writing your unit in all equations. This is very, very important. So this is, we can change our delta W into standard form, but it is at will. It's not compulsory, but it is necessary. So delta W is in the standard form will be 3.41 times 10 to the 5. Now how do we change to standard form? We know that the decimal place is at the last point, so we shift the decimal place. We have 1, 2, 3, 4, 5. We have shifted 5 times to the left. So when we shift it 5 times to the left, the power of 10 will be positive, and it's positive 5 because you have shifted 5 times to the left. So we have this in standard form. The Roman 3 part of the question, they said what is the change in the internal energy of the water during vaporization? They said during vaporization, and we know that during vaporization, and we see that here the temperature does not change, so we already know what to do there. Now the internal energy, so from delta Q, which is delta U plus delta W, we have that delta U will be delta Q minus delta W. We don't know delta W, but we can calculate it. We have the mass, so delta W or delta Q is equals to M LV, which is the specific latent heat of vaporization of water, and it's a standard value of which you have just given here. So we have 2.00 kilogram times 2.26 times 10 to the power 6 joule per kilogram, which is equals to 4.42 times 10 to the power 6 joule. You can punch your calculator. So Remember that specific Latin heat of vaporization is the standard or is the heat required to change the state of a substance from liquid to vapor without a change in temperature. Remember that there we had 100 degrees Celsius in the liquid state and 100 degrees Celsius in the vapor state. So no change in temperature. So we have our delta Q as this. Now we know delta W that you have calculated it before. It means that delta U will be 4.52 times 10 to the power 6 joule minus 3.41 times 10 to the power 5 joule. And calculating it using your calculator, we have 4.18 times 10 to the power 6 joule. So we write our answer in a box form for it to be more presentable. So guys, we have come to the end of this video, and if the video is interesting to you, I invite you to like, comment and share the video, and not forgetting that your comment is what makes us to do more videos again and again. Also subscribe to the channel and activate the notification bell to not miss any of our video that will be uploaded very soon. So stay tuned on our YouTube channel, and not forgetting that in science, consistency is the key.